This is the last part of section 8.5, just finishing up different ways to build linear equations. This is an application example. You'll see one or two of these in your homework. It says Southern Star Realty is an established real estate company that has enjoyed constant growth in sales since the year 2000. In 2002, the company sold 200 houses, and in 2007, the company sold 275 houses. Use those figures to predict the number of houses this company will sell in the year 2018. So just a few things to look at here. The word constant growth tell you that it's a linear equation. And it's giving you 2 points in time. You've got 2002, they sold 200 homes, and in 2007 they sold 275 homes. To make this a little bit easier on us, we're going to consider the year 2000 kind of a zero. So 2002 will just be 2, and 2007 will just be 7. Keep things a little bit easier. So 2018 will just be 18. So the first thing we want to do is find the pattern. We want to figure out how fast are they growing. Finding the pattern is the same idea as finding the slope. Once we have the slope, then we can build an equation to use, just like we were practicing. So these two things are very similar to what we just did, finding your slope, picking a point, building your equation. Once we've built an equation, though, we're going to plug in to make the prediction. And so I gave you this full sheet of paper, and you of course have extra paper if you need it. So we're going to find our slope, we're going to build our equation, and we're going to plug in our predicted year to make a prediction for how many houses that they will sell. So we need to find our pattern. We know in 2002, and I'm just going to use 2 for 2002, they sold 200 homes. That's 1 point in time, kind of like the leaking water faucet where you just pick 2 points in time. We also know in 2007, and I'm just going to use 7, they sold 275 homes. So those are 2 points in time that we can use to find the pattern or the slope. So to find the slope, we have 275 minus 200, the difference between the number of houses they sold, and the difference in the years, 7 minus 2. So 275 minus 200 is 75, and 7 minus 2 is 5, and then 75 divided by 5 is 15. So they're selling 15 houses per year. On average, 15 houses per year. More and more and more. So that's our M, 15. From there, we want to pick one of the 2 points in time, whichever one you like. I like even numbers, so I'm going to go with this one. And we're going to use our slope and our point to build point-slope form. So we have y minus 200 equals 15 times x minus 2. From there, we'll do the same thing we were practicing earlier. Y minus 200 equals 15x minus 30. Then we'll add 200 to both sides. So y equals 15x plus 170. So that is their equation for growth. And they pay analysts at real estate companies to figure these things out. They pay them big money to figure these things out. There's also very expensive software that someone created and made a lot of money off of to figure these things out. So we're doing it by hand, but people get paid big dollars to figure these things out and to write software to help. So now that we have this equation for growth, we can plug in any year we want and make a prediction to how many houses they will sell. The year they're interested in is 2018, so we're going to use 18 as our x value. So we're going to take the 18 from 2018 and we're going to plug it in where we see x, and you will want a calculator for this. These numbers are pretty big. So we have y equals 15 times 18 plus 170. So let's see here. 15 times 18 is 270, and then plus 170. So we have 270 plus 170. So it's predicted that they will sell 440 homes in the year 2018, assuming they still have that nice constant growth. So pretty long procedure here. We found a pattern using the points in time that they gave us. We built an equation from that pattern like we practiced earlier, and then we plugged in whatever they're curious about, and you can use whatever year. They used 2018. Plug that in to our equation to make our prediction. So you'll have one or two of these in your homework. They're not too difficult to work with, but it is a long process. And last but not least, we're going to talk just a little bit about parallel and perpendicular lines. So we've seen this before in the slope section. We know parallel lines have the same slope, and that perpendicular lines, a little bit more complicated, they have opposite reciprocal slopes. So remember, opposite is positive, negative. Don't know why I put a 1 there. Positive, negative. And reciprocal is when you flip the fraction. Alright, so let's see. It says use the given information to write an equation for a line in slope-intercept form. Remember, that's our finished form with the following requirements. So point-slope form is going to come in handy again. Remember, this is our rough draft form. This is where we start. Then we'll rearrange it as needed to get it into slope-intercept form. So I'm going to have that card handy for you. It says through the point 4, 4, parallel to the line 2x plus 3y equals 6. So for this one, in order to get anything done, the first thing we need to do is find that slope. And we practiced this before. We have an equation in standard form. In order to find the slope, we're going to have to solve for y. So if I have 2x plus 3y equals 6, you can move that 2x to the other side. That's going to give me 3y equals negative 2x plus 6. And then I can divide everybody by 3. That's going to give me y equals negative 2/3 x plus 2. I don't really care about the plus 2. I care about the negative 2/3. That's what I need for my other equation. So I'm going to use this slope because we want it to be parallel, this slope, and this point to build my equation. So I'm going to have y minus box equals blank times x minus box. I'm going to use the point 4, 4 and the slope negative 2 over 3. Before I continue, I want to kill that fraction. So I'm going to multiply both sides by 3. Distribute on the left, cancel on the right. I'm going to go ahead and distribute this negative 2 just to save myself a little bit of writing, and the 3. So I have 3y minus 12 equals negative 2x. It's going to become plus 8. You always move your constant to the right, no matter what. That gives me 3y equals negative 2x plus 20. And then divide everybody by 3. And I'm doing that because I know I want the final answer in slope-intercept form. And this gives me the final equation y equals negative 2/3 x, which that should match since they're parallel. And then 20 over 3 does not divide nicely. It's going to have a different y-intercept. So there's my equation with that slope through that point. So let's go over that again. You have to find the slope for the equation they gave you. So use that equation, find that slope. If we want it to be parallel, we're going to use that exact same slope in our equation, and the point that they gave us. So point slope form, just like we practiced before, and then you're going to put your final answer in whatever form it specifies. Let's look at another example. So it says through the same point, so 4, 4, this time perpendicular to the same line from part A. So because we're using the same line from part A, I just did this to save you a little bit of time, we already have the original slope. So the original slope is -2, 3. The perpendicular of that, so we're not just going to use that slope again, we want the perpendicular of that, is instead of negative it'll be positive, and instead of 2 over 3 it will be 3 over 2. So that is the slope I'm going to use for my perpendicular line. So let's see, we're going to have y minus box equals blank times x minus box. I'm going to use the same point 4, 4. And this time the slope I'm going to use is 3 over 2. I'm going to go ahead and kill that fraction right from the beginning. Multiply both sides by 2. Distribute my 2. Kill the 2 over here. So, and I'm going to distribute that 3 at the same time. It's going to give me 2y minus 8 equals 3x minus 12. So it gets a little messy, and then it cleans right up and it's easier to see. So I'm going to move my constant. That's going to give me 2y equals 3x minus 4. And again, it wants it in slope-intercept form, so I'm going to divide everybody by 2. So that gives me a final answer of y equals 3 halves x. And negative 4 divided by positive 2 will be minus 2. So again, it has that perpendicular slope with a different y-intercept. That y-intercept corresponds to the point that it's going through. So again, that's just applying what we've learned to parallel and perpendicular lines. The second half is the same idea, but instead of having slope-intercept form as the final form, we want standard form as the final form. So I encourage you to pause the video, try these two on your own, see how you do, and then play the video back to check. But let's go ahead and go through these. Again, if you've paused, that's fine. If not, you can just follow along. So let's see, we've got our equation 3x plus 4y equals 1. I've got to get the slope from that, so I'm going to move my 3x to the other side. This is what we practiced at the very beginning of, I think it was section 8.4. And divide by 4. So we're going to have y equals negative 3/4 x plus 1/4. I don't really care about that equation. The only part I care about is the slope of that equation. And we're going to be doing parallel to that slope. So the same slope using the point they gave us. So that's the first part, is solving for y, getting that slope. A lot of students just stop there, but that's just the very first step. From here, I'm going to use point slope form. Y minus box equals blank times x minus box. I'm going to fill in what I have. 8, negative 3, using this slope, negative 3/4. Let's see here, let me clean this up. Anytime I have a minus and a negative, I like to clean it up so I don't forget about it. And then I'm going to kill the fraction because I don't want to see it anymore. The 4's cancel on the right, distribute on the left. Oops. And I'm going to distribute this as well so I can get it all done in one step. So that gives me 4y plus 12 equals negative 3x. That's going to become plus 24. And I'll move the 12 to the other side. And that's going to give me, I'm going to write it over here so we can see it, 4y equals negative 3x plus 12. And I would divide everybody by 4, but the directions say standard form, So because it says standard form, I'm going to move that 3x to the other side instead. So that's going to give me 3x equals, oh, just kidding, 3x plus 4y equals 12. And that leading coefficient is positive, and all the values are integers. So again, I move the 3x to the other side. That gives me 3x plus 4y equals 12. So it's in standard form. I know it's parallel to this line because I use the same slope, and I know it goes through this point because that's the point I plugged in. Let's do that one last time through the same point, perpendicular to the same line. So that saves me a little bit of time here. I know the original slope was negative 3 over 4. To make it perpendicular, it was negative. I'm going to make it positive, and instead of 3 over 4, I'm going to make it 4 over 3. So I'm not going to use the original slope. I'm going to use the perpendicular slope through that same point, 8, negative 3. So I have y minus box equals blank times x minus box. Let's see, my new slope, my perpendicular slope is 4/3. My x value is 8. My y value is negative 3. So that's going to give me y plus 3 equals 4/3 times x minus 8. I want to get rid of that fraction as soon as I can. So I'm going to multiply sides by 3. Where's the denominator? It just cancels the denominator on the right. Distribute on the left. From here we have 3y plus 9 equals 4x minus 32. I'm going to go ahead and distribute that as well. Move my constants to the right. So I have 3y equals 4x minus 41. It wants the final form in standard form, so instead of dividing everybody by 3, I'm going to move that 4x to the other side. I'm going to bring this over here. So I have negative 4x plus 3y equals negative 41. And almost done, but that leading coefficient is negative, so I'm going to multiply everybody by negative 1, and that will fix that problem. For our final answer of positive 4x minus 3y equals positive 41. So again, this is a process. It's a lot of algebra, a lot of manipulation. You really have to keep up with what piece of the step you're on. If this gets a little too messy, I always encourage rewriting it on a clean sheet of paper using colored pencils to help you see what step you're on and not getting anything jumbled up. You have to pay very careful attention to the signs, very careful attention to what side of the equation you're working with to get these exactly right.